It's Miss Summers with your notes today on erosion. So just to catch you up to speed, we've started our fourth unit. Last week we looked at the rock cycle and the different types of rocks, metamorphic, igneous, and sedimentary, and the different kinds of those rocks like intrusive and extrusive, and foliated and non-foliated, and clastic, bioclastic, and chemical, all that fun stuff. And then on Friday, we talked about weathering and how weathering is the breakdown of rocks into sediments. And we know that weathering can be one of two things. It can either be mechanical, where a rock is physically broken down, but it's still the same kind of rock, just in smaller pieces, or chemical, where a chemical reaction takes place and that breaks a rock down into something new. All right. With weathering, often weathering and erosion are talked about together, but they're not the same thing. So that's why I've separated them into two different days. All right. So we will look at what erosion is and some of the agents that cause that. All right. So let's define erosion. We know that weathering is the breakdown of material. Erosion is the movement of that material by natural agents. All right. We're going to talk about movement or erosion of materials by water, wind, and gravity. We'll look at those three. Okay? So water is a powerful agent of erosion. It's probably the one that you're able to see easiest. This can be in the form of rain, streams or rivers, or even ocean dynamics. So this picture right here, we have the majestic Grand Canyon. If you've ever been there, it's a wonderful place. I haven't. I assume it's nice. All right, it's one of the natural wonders of the world. This canyon was carved by this river. By the erosion, this river, the Colorado River, carried over millions and millions of years, has weathered, chipped away at these rocks, and carried them downstream. All right. We also have glaciers. We're going to count glaciers as water because they are ice, so it's technically the hydrosphere still. And then we also have erosion by wind and by gravity. All right. So let's start with water. How does water erode things? Water picks up sediment and carries it away. Okay, so here we have somebody's house or whatever. You can see the erosion here. You can see the rainwater flowing across the surface. It's carrying little sediments in it. These sediments are going to go from one place to another. Rain can cause these little land formations to form. If you've ever seen something like this out in a field, this is called a gully. So this is the action of rainwater plus a little bit of gravity helping, and you get these little gullies forming. All right. Streams and rivers. We're going to talk about rivers a whole bunch next unit. Woohoo! It's the water unit. Woo! Small sediments like sand and silt can be carried farther. All right, streams are going to pick up sediment and carry it down towards the mouth of the river. Whoops. In a stream, and we are going to look more at this next unit as well. When water changes speed, its ability to erode changes as well. So where water slows down, so on this side or this side, so this area is called a meander in a river. On the slower side of the meander, sediments get deposited. They get put down. That's the opposite of erosion. Erosion is going to happen where the water is the fastest. All right, if water is faster, it has more energy, it can carry more things. All right, there's different factors that are going to affect erosion by water. So I'm going to mute my volume. We're going to look at this experiment that this fellow is conducting. We want to look at what's the variable, how does it affect erosion of soil by water. So let's take a look. We're going to say no ads, YouTube, no ads. And it does a very good. Fantastic. Okay, so here's a guy. He's got 3 different containers here. And you can see they have varying degrees of plant cover. So this one's over here, no plants. The one in the middle is covered by dead leaves. And the one over here on our left, his right, is plants, grass, that's growing in the soil. So he's going to pour the same amount of water into each of these, and the water's going to catch in these little containers. If erosion happens, the soil will get carried into here. All right, so let's take a look at the first one. So he puts the water in. So this would be like an empty field or a construction site. It's raining, it's raining, it's raining. And then there's too much water, so the water starts to run off. And there we go. So you can see that the water that's coming out there at the bottom has a lot of sediment in it. That's a very high rate of erosion. There's lots of dirt in that water, okay? Because there was nothing to hold on to the soil. All right? Now, if we go to the next one, the one in the middle, this is just leaf cover. There's still soil in the bottom, so let's see how much erosion happens there. So he puts the water in, blah, 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 blah. It's going to happen any second now. And here we go. All right. Note the difference between the one on our right and the one that's in the middle. Even with just the dead leaves covering the soil, that prevented a lot of erosion. Not a lot of that sediment got carried out. Only that much did. You can see it floating on the top there. Now let's look at the last one with plants in it. Okay, so again, this is grass growing in dirt. So the water is moving through the soil, but the soil doesn't erode. There's no erosion here. If you look at that water, it's pretty clear. There's not a whole lot, if any, erosion happening at all. And the reason is the roots of the plants, go back to my PowerPoint. The roots of the plant hold the soil in place. Roots of plants will prevent erosion. All right, let's look at ocean dynamics. Ocean dynamics is fun. All right, tides and waves carry away weathered material. All right, so this carrying away of sediments can affect landscapes on a really, really big scale. Here is a good old Cape Hatteras. It is one of our state landmarks. Wonderful historical treasure. All right, Cape Hatteras is a lighthouse on the Outer Banks, which is a barrier island. And as you can see, this was about, 15 years ago or so, back in the early 2000s. Cape Hatteras was in a lot of trouble because the ocean was eroding away the beach. So in a few years, this ocean would have been right here at the base, and we were at risk of losing this wonderful little lighthouse. So they were like, well, how do we fix it? Well, they took the Patrick Star approach, and they're like, why don't we take the lighthouse and push it over there? And they're like, that's a great idea. So that's what they did. All right, they took the lighthouse, they raised it off its foundation, and they very carefully moved it to the middle of the island. And you're like, that's really cool, they saved the lighthouse. They did, but the erosion is still happening. All right, let's take a look at how erosion changes barrier islands, because we do live in North Carolina where barrier islands exist. I'm going to put my volume up for this so you can hear this fellow. We're only going to watch the first 2 minutes or so. I want you to listen for how does erosion change the barrier islands? How do the islands change over time? Okay. And we're going to full screen this bad boy.
Today we will discuss barrier islands.
Thanks, Dr.
What
Elmore.
are barrier islands?
What are they?
They are thin, long islands that are separated from the mainland by a bay, lagoon, or marsh, and they're separated from each other by tidal inlets. Major parts of a barrier island include the beach, the dunes, and the marsh. And there are several processes that shape barrier islands. There are 4 of these processes. One of the most important one is called longshore drift.
So wait, listen to this.
As you see in this figure, as waves come in at an angle, they break and move up the beach. But when the water moves back down, it's going to follow the steepest path. So the water and the sediment that's being moved by the water follows a zigzag pattern. And so sand and water move down the beach. That's called the longshore drift. It's a very important process. One consequence of longshore drift is that if you have a tidal inlet and the longshore drift is, say, one direction, what's going to happen? It's going to add sand to one side of the tidal inlet, but the tidal inlet wants to maintain its opening because the tides have to go in and out, so you get erosion on the other side of the tidal inlet. As a result, tidal inlets can migrate. The third process that operates on a barrier island is the summer-winter change, which is caused by changes in wave energy. In the summer, there's lower wave energy and sand is added to the beach. Sandbars move onshore and the beach becomes wider. In the winter, there's higher wave energy and the sand is eroded and stored offshore. The fourth process is overwash fans, and this occurs during large storms or hurricanes. What happens is sand is moved from the beach to the back part of the barrier island. It usually shows up as a tongue of sand that goes from the beach to back into the marsh area, the back part of the barrier island. It's a very important process because it moves barrier islands landward.
All right. So we had our three main ways barrier islands move or change over time. The tidal inlets can move because the longshore drift adds sand to one end of the island and takes it away from the other. We have the overwash fan that moves the islands towards land. And then we have the summer-winter change. In the summer, the beach expands. There's more deposition because the wave energy is lower. And then in winter, more erosion happens. All right, so in this map, you can see this is the outline of one of the barrier islands that Cape Hatteras is on. So it used to be all the way out here into the Atlantic Ocean. Over time, its erosion has caused the island to push backwards. All right, so 1999 is when they moved that lighthouse. All right, cool. All right, and our last erosion by water are glaciers. Or glaciers, however you say it. It's fine with me. So a glacier is an ice field that flows downhill. The ice drags material and scrapes the surface. So that scraping is like weathering because it's breaking stuff up as it moves along. How glaciers erode things is they move stuff, they push things along, and then it puts them down somewhere else. Some parts of glacial erosion that I want you to know. I want you to know that a moraine is the debris that's pushed up and forward from an advancing glacier. So here's a terminal moraine. All right, this was material that was in front of the glacier and it's pushed it forward. And then we also have an erratic. All right, if you've ever seen a field kind of like this and there's like random boulders everywhere and you're like, how did these boulders get here? Like what's going on? That's evidence that there used to be a glacier and those boulders were picked up and moved by the glacier and then deposited when the glacier melted. So the glaciers pick things up and put them down. Pretty good. All right, let's look at wind transport. What I want you to know about wind is that it carries fine, dry sediment, and it can carry it a very long way. All right, sand dunes. All right, again, if you've ever been to like the Outer Banks or a barrier island, you see those big piles of sand. That's a sand dune. That's erosion by wind. The wind is going to pick up the top layer of sand and carry it elsewhere. We've already actually seen this video, or I've made you watch this video when we talked about spheres of the earth, how erosion in the Sahara Desert, so the wind picks up the sand in the Sahara and it travels all the way across the Atlantic Ocean and drops it and deposits it in the Amazon rainforest. And that's a good thing because the rainforest needs the phosphorus in the sand in order for the plants to grow. All right, so this erosion happening here actually ends up benefiting somebody else somewhere far away. All right, and our last agent of erosion, so we have water, wind, lastly is gravity. All right, I'm not gonna make you memorize like the difference between like a creep and a slump and a landslide and all that mess. Just know that gravity erodes things downward because gravity pulls stuff down. It's usually really fast, or it's faster than like erosion by water or wind. You get like a big change really fast. And this term is mass wasting. Mass wasting. Okay, so a bunch of it moves really, really fast. All right. That concludes our notes on erosion. So we have erosion is, just a quick recap, erosion is the movement of things, not the breakdown. It's the movement of sediments by wind, water, or gravity.